Good morning, students. Welcome to the second session of Standard 10 Science 1 Chapter 1 Gravitation. Students, in the last video, I had tried to explain you the difference between gravity and gravitation using two bottles of different sizes. With that example, I wanted to draw your attention to the fact that though the force of gravitation exists between the two bottles, still there is no effect of this force on the bottles. We had assumed that the pull on the small bottle is greater than the pull on the big bottle, and hence I had told you to imagine. I repeat, imagine the small bottle in motion towards the big bottle. Actually, neither of the two bottles move towards each other because the force of gravity is much stronger than the gravitational force, and the force of gravity does not allow the bottles to move. Also, force of friction resists their motion. But the question still remains regarding the magnitude of the force of gravitation between the two bottles. The force of gravitation is an attractive force existing between any two objects that have mass. This force pulls the objects together, that is, one should exert force on the second and the second should exert force on the first. Now students, you had studied in class 9 Newton's third law of motion, which states that to every action there is equal and opposite reaction. I repeat, to every action there is equal and opposite reaction. So according to Newton's third law, if big bottle exerts force on small bottle should also exert equal and opposite force on the big bottle. This means a definite force of attraction exists between the two bottles. That is, they pull each other with equal and opposite force. Now, you all know the force equation, which is given by the formula F is equal to ma. The force equation is an important equation in physics, and it is given by the formula F is equal to ma, where a is the acceleration and m is the mass of the body. So, if we keep F as constant, then a is equal to F upon m. That is, a becomes inversely proportional to m. So, keeping F constant, a becomes inversely proportional to m. This is from the force equation, which comes from Newton's second law of motion, that is called law of momentum. This means that more the mass, less will be the acceleration, and less the mass, more will be the acceleration if we keep F as constant. So, the big bottle has more mass and hence will have less acceleration. Small bottle has less mass and will be accelerated more towards the big bottle. And hence I had asked you to imagine the small bottle to be pulled by the big bottle, but actually the bottles don't move towards each other, and you very well know the reason for their not moving towards each other. That is because of the force of gravity. That force doesn't allow them to move. Now coming back again to the force of gravitation between the two bottles. If F1 is the force exerted by big on small and F2 the force exerted by small on big, then by Newton's third law of motion we get F1 is equal to F2 is equal to a constant, say F. This F is a constant force that is equal and opposite to each other. That is, both the bottles will exert the same force F on each other, but their direction will be opposite. One will act on 2 and 2 will act on 1. Now, the question is, how much is this force, the force of gravitation between the two bottles? What is the magnitude of this force of gravitation between the two bottles? So, in order to find out how much force of gravitation exists between the two bottles, Sir Isaac Newton has given a law called Newton's universal law of gravitation. So come on, let's watch the next video to understand Newton's universal law of gravitation.
we saw that the gravitational force is the attractive force between any two objects with non-zero mass separated by a distance. So does the apple fall towards the earth, or does the earth move towards the apple? Or do both move towards each other? It's actually simple logic. This is the earth, and say this minuscule object is an apple. Based on what we learnt about the gravitational force, both apply an equal force to attract the other object towards itself. So if the forces are equal, which one will accelerate more? Based on the Newton's second law, we know that the force applied is the product of mass and acceleration. So the acceleration will equal force over the mass. The acceleration is inversely proportional to the mass. If the mass is more, the acceleration will be lesser. As the mass of the earth is much more than the mass of the apple, it is the apple that accelerates towards the earth and not the other way around. Hope that makes it clear. Now the question is, how do we quantify this force? To understand this, we need to understand a simple concept. And this simple concept is called the universal law of gravitation. Say there are two objects A and B separated by a distance d. The distance between the centers is considered the distance between the two objects and not this distance. Assume that the mass of object A is m1 and that of object B is m2. As object A is bigger, let's assume m1 to be bigger than m2. The universal law of gravitation says that every object in the universe attracts every object with a force which is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. Let me repeat. The force is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. With this data, we can write it mathematically like this. So if the mass of any of the objects increases, the gravitational force will have more magnitude. And more the distance between the two objects, the lesser will be the gravitational force. Directly proportional to the product of the masses and inversely proportional to the square of the distance between them. This can be written as F equals G times m1 times m2 over d squared. G here is the constant of proportionality and is called the universal gravitational constant. The equation can be modified and written as G equals F times d squared over m1 times m2. The value of G was found out by Lord Henry Cavendish using a torsion balance. The universally accepted value of G is 6.673 times 10 raised to negative 11. What will be the units of G? Force is newtons. As the distance is in meters, we have meters squared. And as the mass is measured using kilograms, we multiply this with kilograms raised to negative 2. This is the value of the universal gravitational constant.